Today we'll be learning about multi-digit division, multi-digit division word problems, powers of tens, and exponents. So starting with multi-digit division. So number one says 184 divided by 8. And in order to do this, we're going to set up an equation that looks like this with 4 at the top. And how many times can 4 go into 1? It can't go in, so we gotta go to the next one. So how many times does 4 go into 18? It could go in 4 times, which is 16. 4 times 4 is 16. You subtract that, you get 2. You bring the 4 down. How many times can 4 go into 24? You have 6. So number 1 would be 46. So 46 times 4, if you do it, it's going to equal 184. So number 2, we're going to do 702 divided by 9. 9 can't go into 7 anytime, so we got to do, how many times can 9 go into 7? And it's going to be 6 times. No, it's going to be 7 times, which is going to be 63. 9 times 7 is 63. We subtract. 70 minus 63 is 7. We bring that down 2. How many times does 9 go into 72? 8 times. So 8 times 9 is 72. And we get 72 minus, so we get 0. So number 2 would be 78. And we'll just do one more. 192 divided by 3. 3 goes into 9 6 times, because you get 18. 3 times 6 is 18 minus. So 1, you bring down the 2. You get 12. 3 times 4 is 12. So number 3 is equal to 64. Now we'll move on to multi-digit word problems. So it says, for number 1, it says there are 98 chairs set up in the gym for an assembly. After the assembly, all the chairs will be put away on rackets that hold 7 chairs. How many rackets are needed? So you got to do 98 divided by 7. 7 goes into 9 one time. There's 2 left, and then you bring down the 8. And then 7 times 4 equals 28. So there'll be 14 racks. 14 racks needed. 14 racks. Now we'll do number 2. A group of 117 business people need to take a shuttle van to the airport. If each shuttle can take 9 people, how many vans will the business people need? So we'll do 117 divided by 9. 9 goes into 11 one time. So it becomes 27. Since you bring down the 7, 9 times 3 equals 27. So you'll need 13 people. 13 shuttle vans. And let's do number 3. There are 768 chairs set up in the gym for an assembly. After the assembly, all the chairs will be put away on rackets that hold 4 chairs. How many racks are needed? So this is the same one as number 1, except for we have 768 chairs and we have to divide that into 4. So 768 divided by 4 goes into 7 ones. You do 4 minus, so it becomes 3. You bring down the 6, and it goes into 4 times 9 is 36. So we have a 0, and we just bring down the 8, and then 4 times 2 equals 8. So we get 192 racks. Now we'll go on to powers of 10. So for powers of 10, it can be 10, 100, 1000, and so on. So you just gotta add a 0 for each 10. So since this will be 10 to the power of 1, right? This is 10 to the power of 1. And then the one with 2 tenths is to the second power. This is to the third power. And 4 power would have 4 zeros, which would be 10,000. So number 1, 10 to the second power is 100. 10 to the first power is 10. And 10 to the 0 power, anything to the 0 power is 1. 10 to the 6th, it's going to be 1, 2, 3, 4, 5, 6. So it's going to be like 1 million and so on. So we'll try doing 7, which is 0.4 to the 8th power. And what that means is you just got to move it 8 decimals. 1, 2, 3, 4, 5, 6, 7, 8. And then you just got to add the zeros in here. So you'll get 40 million, right? Because you got to move the. This is basically telling you to move the decimal points, this much points to the right. So pretend, yeah, we'll just do number 9, just 2. So you move the decimal point from here 1, 2. So it's going to be 0.7. All right, and then on to the last one, which is exponents. And if this is 3 to the 3rd power, all you're going to do is just basically multiplying 3 times 3 times 3, which equals 3 times 3 is 9, 9 times 3 is 27. And then 5 times to the 2nd power, which means you just multiply 5 times 5. So whatever the exponent is, that's how much times you multiply your number, which equals 25. And 7 to the 0 power, and as I said, anything to the 0 power, right? Pretend x to the 0 power. X could be any number. Like pretend it's 1 million to the 0 power, it's going to equal 1. 5 to the 0 power is going to equal 1. 6.3 to the 0 power equals 1. So anything to the 0 power equals 1. And also pretend anything to the 1st power equals itself. So pretend it's 1 million to the 1st power equals 1 million. Like 3,762 to the 1st power equals 3,762. So whatever is equal to 1 is equal to the same thing. Okay, it becomes itself. And we'll just do like one more. Let's do number 9. Oh, actually, let's not do that one. Let's do number 7. 8 to the 2nd power, which means you multiply 8 2 times and you get 64. And let's just do number 2. 2 to the 6th power, which means you multiply 2 6 times. Yep, 6 times. And 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. And 32 times 2 is 64. So you get 64 as your final answer. And thank you for